Hi, my name is Roberta. Welcome to this journey through science. Today, we're diving into one of the most fascinating parts of modern technology: quantum computing. In this session, we'll explore how it works, why it's important, and what it could mean for the future. We'll look at the mysterious world of tiny particles, how they behave differently, and how scientists are using that to build powerful new machines. Get ready to explore science and tech that seems like it's straight out of a sci-fi movie. Introduction. This session is all about connecting the mind, matter, and the cosmos. Quantum computing is a key part of that because it helps us understand how the universe works on the tiniest scale. We'll learn what makes quantum computers so special, how they can solve problems faster, and how they might change our lives. By the end, you'll know the basics of qubits, quantum gates, and real-world uses, and you'll see how this new tech is creating exciting careers for future scientists. Foundations of quantum theory and classical models. Let's start with where it all began. Classical computers work using bits that are either 0 or 1, like tiny light switches. But in the early 1900s, scientists like Einstein and Schrödinger discovered strange behaviors in atoms. These ideas became quantum theory. Quantum computing builds on that to do things normal computers can't, like exploring all possible answers at once. What is a qubit? A qubit is short for quantum bit, and it's the smallest piece of information in a quantum computer. Unlike a regular bit, a qubit can be 0, 1, or both at the same time. That's a superpower called superposition. Qubits are made from particles like electrons or photons and can be controlled using special machines. This flexibility lets quantum computers solve big problems much faster. Understanding superposition. Imagine spinning a coin. It's not heads or tails until it lands. That's what superposition is like. A qubit stays in a mixed state until it's measured. This allows quantum computers to try many solutions at once, instead of one by one like regular computers. Superposition gives quantum computing its amazing power. Exploring entanglement. Entanglement is when two qubits are connected in such a way that changing one affects the other instantly, even from far away. Einstein called it spooky action at a distance. It sounds magical, but it's real and proven. This helps quantum computers communicate and work together with more accuracy and speed. Classical versus quantum information. Classical information is fixed. It's either 0 or 1, but quantum information can be both, and it changes when you look at it. That's why quantum computing can handle way more data at once. But it also means quantum systems are very delicate and need special care. Quantum logic gates overview. Just like classical computers use logic gates, quantum ones do too, but they're smarter. Quantum gates control qubit states in ways that allow for powerful calculations. These gates are the basic building blocks of all quantum circuits. They let us design how a quantum computer thinks. Common quantum gates. There are many types of quantum gates. The Hadamard gate puts a qubit into superposition. Pauli gates rotate the qubit's direction. The C0 gate links two qubits, creating entanglement. Together, these gates let us create quantum programs to solve hard problems. Quantum circuits and their functions. Quantum circuits are made by connecting these gates in sequences. Each line represents a qubit's journey, and gates change their state. At the end, we measure the qubits to get the answer. These circuits are the foundation of quantum algorithms. Grover's algorithm. Grover's algorithm is like a super search engine. Instead of checking every result one by one, it finds the right answer in fewer steps. It's great for solving puzzles or searching huge databases. Quantum computers do this with amazing speed. Shor's algorithm. This one's a game changer. Shor's algorithm can break big numbers into factors really fast, something regular computers struggle with. That's a big deal because it could break today's online security. So, scientists are working hard to make new, safer ways to protect our data. Challenges in quantum hardware. Quantum computers are still very fragile. Qubits need to stay super cold and quiet, or they'll mess up. It's hard to build large systems that stay stable. That's why we're still in early stages, but improving quickly. Quantum error correction basics. Because quantum computers are so sensitive, they make mistakes. Error correction spreads one qubit's info across many others. This lets us detect and fix errors before they ruin the result. It's like giving quantum computers a safety net. Practical applications of quantum computing. Quantum computers can do amazing things. In medicine, they help discover new drugs. In finance, they make better predictions and detect fraud. And in AI, they train smarter robots faster. These machines are already starting to help real industries. Quantum in cryptography and AI. They're also helping make and break digital locks. Quantum computers could hack today's security, but also create better ones. In AI, they help machines learn faster and solve tough problems. That's why companies and governments are investing big. Quantum industry adoption. Big names like Google and IBM are racing to build quantum machines. Startups are also joining in with new ideas. Governments are funding research to stay ahead. It's a booming field with lots of excitement and competition. Quantum careers, what to explore. There are tons of jobs in quantum tech. You could write quantum programs, build new machines, or study particle behavior. Whether you love coding, science, or engineering, there's a place for you. Start learning now, and you could work in this future. Skills for quantum tech careers. To prepare, focus on math, physics, and computer science. Learn programming languages like Python and tools like Qiskit. Mix your learning across science and tech. These skills will help you in any quantum job. Recap and what's next. We've covered a lot. From qubits and entanglement to real-world uses and jobs. Quantum computing is still new, but it's growing fast. Stay curious, ask questions, and keep exploring. Maybe one day, you'll help build the quantum future.